हेलो डियर स्टूडेंट, मैं पाथफाइंडर आपका फिजिक्स मेजर। आज मैं फिर से पाथफाइंडर का एक लॉज ऑफ मोशन का चेक योर अंडरस्टैंडिंग का सम आप लोगों से डिस्कस करने जा रहा हूँ, जिसको मैंने बोर्ड पे शेयर कर रखा है। आई होप आप सभी को दिख रहा होगा। एल्स अगर आपके पास बुक हो देन यू कैन गो थ्रू द बुक एंड यू कैन चेक दिस प्रॉब्लम। बट इस प्रॉब्लम को सॉल्व करने से पहले मैं शेयर करना चाहूँगा, if you people have gone through the problems of general physics by Irodov, then आपको ये सम्स करने में और मजा आए। The reason, the concept which is involved in doing this sum is very much similar to Irodov। तो मैं आप लोगों के लिए वो Irodov का सम भी शेयर कर दे रहा हूँ, अगर आप देख पाए तो Irodov का 1.107 में दिया हुआ है ये सब। आई होप अगर आप लोगों ने किया होगा या जो मेरे क्लास में जो स्टूडेंट होंगे उनको तो मैंने डेफिनेटली इसको डिस्कस किया है। चेन प्रॉब्लम, वेज प्रॉब्लम, स्फीयर पे रखा हुआ है, इससे रिलेटेड सारे जगह सेम कंसेप्ट है जिसको क्विकली हम लोग सॉल्व कर पा रहे थे। बट जो मेरे चैनल के थ्रू जो स्टूडेंट इसका बेनिफिट उठा रहे होंगे उनके लिए मैं जस्ट 1 मिनट में इस क्वेश्चन को सॉल्व कर रहा हूँ। क्वेश्चन को अगर आप देख लें, a chain of length L is placed on a smooth spherical surface of radius r। ये दे रखा है, a chain of length L is placed on a smooth spherical surface of radius r with one of its end fixed at the top of the sphere. What will be the acceleration of each element of the chain when its upper end is released? It is assumed that the length of the chain is L which is less than pi r by 2. What does it mean? अगर आप यहाँ टॉप एंड में ऐसा मान लो अगर चेन को कि चेन इज लाइक दिस, then you know in 1/4 this is your top end and this is 1/4. The 1/4 length will be pi r by 2. So it's telling that this is less than pi r. What does it mean? This is the length of the chain up to here will take, means it's making some angle like this, and this radius is r. So I think this theta can be written as r theta is equals to L. So from here theta can be written as L by r, that we can calculate easily. And the concept which I have discussed in the class, based on that you can find this length. How much it is? You have dropped this perpendicular line up to here. So this length will be your r cos theta. So this will be r minus r cos theta, means this is coming this. So suppose you are going to delete, or one can say if it was fixed with some roof here like this, arrangement was like this, and one has cut it like this. One has cut and the chain is released. So from here directly we can write the acceleration would be r1 minus cos L by r g by L. This is the answer. Here we have seen how to calculate the acceleration. Even I have discussed the concept behind this during the class. The same concept I am going to use in this sum also. Here it is given that there is a one hemisphere on which chain is placed like this. So you have to find where the rope will have maximum tensile force. So if I draw the sphere again like this, whatever is given hemisphere, but it does not matter whether it is a sphere or hemisphere. we can assume there is a one support in which the arrangement of chain is like this. Suppose. And someone has cut it down like this. And it is going to be released. Its radius is given as small. Then what we can say, after cutting it here, the tension at the initial point will be 0. And here, at the end point, there is no other pieces of the chain is hanging. So at this end also tension will be 0. Means what we can say, if you assume a very small portion of this chain like this, then what we can say, if we start considering the small block like this from here to here, then we can say the component of mg along the tangential direction will be keep on increasing if we start from here to this side. What does it mean? One can say the tendency is like the blocks which are hanging on the other side is pulling the blocks which is on their rear side. We can think in this way, and due to which they are going to attain one acceleration, unit acceleration. So based on this concept, what we can draw the FBD for the given system, then one can say this seems this is going to pull the rear blocks, and again here if you consider the another block, then this is going to pull, but this pulling tendency has a stops at this end, means here also tension is going to be 0. What does it mean? Tension here is 0 and at the other end is also tension is 0. Means somewhere tension is going to be maximum, that we have to find in this question. So based on that, if we draw the FBT diagram, then we can say, say this side there is a tension T, and say here this is a tension T minus T. I am writing in this way. And another thing is, suppose it has this mass dmg in this direction, by assuming this is a small slope of angle of inclination theta. If I draw it here, suppose here this is the inclination on which this dm mass is kept. So in this direction, that is dmg. So in this direction, means along this tangential direction, we can say this is acting dmg sin theta. And this side is t, and apart from t, this side is also t minus t, right? So what force equation we can write and say this acceleration is a, which is a constant. So we can write t minus dt minus t plus dmg sin theta is equals to dm times t. We can write in this, these dt get cancelled. So here minus dt, if we are going to write, then we can say this dm can be written as lambda r dt. Lambda is mass per unit length. So lambda r g sin theta, and here also dm value is lambda r d theta times, where the r d theta is the differential length of this block. We have discussed many times during the class how to take dA, dl, and dv. So everything we have, and I think the student who is watching the video, they must know how to take the differential element and differential area if you are preparing for the JEE advance. So they, based on that, if we integrate it, and here say tension was 0, all right, any angle theta, tension becomes this t as a function of theta, and this is also from, we are imagining the theta from here 0 to this theta, and this is also from 0 to theta. So what we can write, this is coming minus t as a function of theta, and here lambda r g is constant, sin theta d theta integral is minus cos theta. So this is coming 1 minus cos theta. And since here a is constant, so a lambda r is a constant quantity which come outside, and this integral is only d theta integral is nothing but theta. So if you write t theta, then this term will come this side, and if you take lambda r as a common, then what we can write, g 1 minus cos theta, and this side minus a theta. Here we are finding, now we have tension as a function of theta. So after getting the expression for the tension, we need to take its derivative, and according to the derivative, we have this expression. Lambda r is constant, so lambda r cannot be equals to 0. So here we have g sin theta minus a equals to 0. So here we are getting sin theta value is a by 0. And already I have discussed the concept behind this one through the problems of the Irodov just few minutes ago. So now we have to substitute this result in this question. Now our job is done. So after substituting the value theta, we can write sin inverse. The value of a by g is coming r1 minus cos l by r. Okay, divided by, and this is the answer. So dear student, I hope आप लोगों को concept अच्छा लगा होगा. बट हाँ, एक्सेलेरेशन को डायरेक्टली हम लोग कैसे लिखते हैं सिस्टम में, ये कंसेप्ट को मैंने क्लास में बताया भी था. एंड आई होप जो आउटसाइडर स्टूडेंट चैनल को देख रहे होंगे उनको भी बेसिक से भी अगर करना चाहें तो आप एक्सेलेरेशन निकाल सकते हो. उसका भी एक्सप्रेशन मैंने यहाँ से दिया है. अगर आप यहाँ से यहाँ इंटीग्रेट कर दो तो टेंशन 0 to 0 होगा, तो यहाँ से डायरेक्टली आपको एक्सेलरेशन का वही एक्सप्रेशन आपको मिल जाएगा अगर आप बेसिक से करना चाहो. अदरवाइज डायरेक्ट शॉर्टकट में करने के लिए थोड़ा सा उसको टीच करना पड़ता है, जिस कंसेप्ट को मैंने क्लास में डिस्कस किया है. आई होप आप लोगों को ये कंसेप्ट अच्छा लगा होगा एंड आप इसका बेनिफिट लेकर और भी सम्स में ट्राई. तो फिर मैं ऐसा क्वेश्चन सा कंसेप्ट को लेकर नेक्स्ट वीडियो बनाऊंगा जिससे कि आपको बेनिफिट मिले. आज के लिए ओके.